O- Okay, everyone, what we have in front of us is a mess of wires. I hope I can make some sense out of it for you. This is a Make Electronics Chapter 19, Experiment 19 summary. As I mentioned earlier in my earlier videos on this chapter, I did not have the 74HC08 AND chips. They did arrive. So this is a summary of what really was done. What I have here is, over here we have a NAND chip, and here we have an AND chip. And these two, they're both dual input quad gate chips, integrated circuits. The one on the right, the NAND chip, well, this is kind of like in the old Star Trek when the Enterprise had a malfunction and Captain Kirk was split into two, and one was an evil Kirk and one was a good Kirk, but they really needed each other in order to be a whole person. Well, this is what happens here. We plug this thing in. What I have is one of the inputs attached to power, and the other input to VCC, and the other input attached to a push button. So in this one, you can see the light is on. I hope you can see the light is on. Otherwise, if I push this button, the light goes off. Light goes on, light goes off. So that's what we had before. Two high inputs turn the output low. So when I push the button, both inputs are high. That's the NAND chip. So he only responds to negative reinforcement. So as long as one of his inputs has a negative on it, he's happy. But as soon as you both go all positive on him, he shuts down. Over here, we have an AND chip. He likes positive reinforcement. As long as he has negative reinforcement, as long as at least one of his pins is negative, he's shut down. But as soon as one of his pins is positive, he lights up. Now you notice that this one over here was momentary, because over here I have the addition of, you can see it right there, is that diode. It's one of these. A 1N4007 rectifier diode. Charles specified a 4148 signal diode, which I do have, but I didn't have when I set this up, and it worked, so I stuck with it. I'm about to go to Charles's Encyclopedia of Components and read all about the difference, but right now I have it working. Now, the only problem is, you can see this light is staying on. And the only way to turn it off is to cut the power. Cut the power, connect this back up again. Whoops, wrong row. Okay, hook that back up again, start this all over again, press the button and it comes on. However, so that's not real good. I want a way to turn it off. We have a few ways to do it. The simplest way would be, and I'll show you an example right now. We'll take this out, and we will attach it over here to this normally closed push button switch. I have to put this down for a second. I'm connecting the input that came from power to the normally closed push button. Trust me, that's what I'm doing. Here we have it. There's a normally closed push button. So it's closed. We push the button here, and that input is still high as if it was directly to VCC, because this switch is normally closed. I push the button and it turns off. So that works, but that's still not great, because when we have, in effect, this pin is floating, and as Charles says, floating pins are a bad thing in any context. And it's kind of like when you're writing a program with an if statement. If you don't cover all in any language, if you don't cover all the options, you may get unexpected results. Right now, we're getting an expected result, but there's no guarantee that will happen that way in the future. So let's try something else. Let's unplug this. Well, we'll see. Light goes on, light goes off. Now, if we go over here, and this wire, you can't probably really tell that, but it's the output of pin 3 on the NAND chip. So pin 3 is the NAND input. So when that's positive, it will come back here. So we'll make that input 1. So you see that light's on, and we push that button, the light goes on and stays on. We go over here, push this button, light goes off. The light on the NAND chip, the LED in the NAND chip comes right back on again because it's only gone, the input's only gone positive for a second, so the output's only gone negative for a second. So as soon as I pop it back up, the light comes back on again. I could probably fix that by involving some other gates, but that's for a future exercise. So this is my summary of Make Electronics by Charles Platt, exercise 19. I really like this. I learned a lot. I'm glad my chips didn't come from China. Light goes on. Light goes off. Sorry, I didn't, if I blocked that. Light goes on. Light goes off. So we have latching, we have connecting 2 chips together, we have all kinds of neat stuff. And I learned a lot because my AND chips hadn't arrived from China yet, so I learned more about the Nord chip. I learned about latching, and in general, it was a lot of fun. Thank you, Charles.